Hey everyone, I hope you're doing well and welcome back to another 4D Systems project video. Today I'll be taking you through the process of how I made this fully playable and functional Snake game controlled by a joystick in Workshop 4 on a Gen 4 display. This is a fun project because it's not just UI, it's real-time input, animation, collision logic, and drawing performance all working together. Let's get started and take a look at how this works. For this project, I will be using a Gen 4 ULCD 2.8 capacitive touch display. I will also be using a Gen 4 UPA breakout board, which I have soldered pins onto, and I will be connecting a joystick module to the breakout board as well. Here is a wiring diagram of the setup for reference. Now that we have gone over the setup, I'll head into Workshop 4 and start building this program. As usual, I'll start with a new project, find my display, and for this project, I'll be working in the Visi environment. Now that we are here, to start off, I'm going to import our image graphics because this project is very code heavy and there aren't many assets that need to be imported. Basically only the background and game over graphic that flashes if you lose. First things first, I'm going to import the background graphic that will behave as a border for this program. It is just a static PNG file. So I'll make sure that Form 1 is selected in the Object Inspector, go down to the Properties tab, and select the image option. This will prompt the File Explorer to pop up, and I'll choose my background image from here that you can see in this window. When I'm happy with it, I can just press OK. And the final step is to change the background type option from color to image. So this will act as kind of a visual border to aid with the empty space on the screen, as well as create something a bit more visually interesting. However, I'm also going to create a lined border in order to show the real constraints on the edge of the program. For that, I'm just going to go to the widgets menu, go to the primitives tab, and drag in a rectangle. Now I can resize and customize this rectangle. I'm going to make its full color black to match the background, and I'm going to make the outline color white. I'm also going to change the pattern to fine to achieve a dotted line effect. That is now finished, and we can move on to the final assets that need to be imported onto the preview display, which is the game over screen that appears if you hit a sidewall or run into yourself while playing the game. This one is pretty simple as well. I'll be using a user images widget, which I can find by going to the System Media tab and selecting and dragging it onto the screen. While the user images widget is selected, I'll then go down to the images option and select it, which will bring up the image list editor window. From here, I can import images that I want to use, which are these game over graphics. I can then press OK and resize and place it where I would like. I'll be animating these using code. That is everything for the setup and importing of this program. So now we can move on to the main chunk of the work, which will be in the code. Let's take a look, and I'll try my best to break it down in a way that's easy to follow. The first thing you will see in the code is a bunch of constants and variables. This is basically where I define everything the game needs to know before it starts running. For example, I set the size of each snake segment, the boundaries of the play area, the joystick sensitivity, and a few values that help control movement and speed. I also set up arrays to store the snake's body, so each segment has an X and Y position, and a variable to track how many segments the snake currently has. Then in the main function, I'm loading the image assets that we imported earlier, the background graphic and the game over graphics. I'm also setting the joystick pins to analog mode and recording their home position. This is important because no joystick rests perfectly in the center, So we measure it once so that any offset doesn't affect the gameplay. After that, I set a couple of timer events. One timer constantly reads the joystick input, another timer updates the snake movement, and a third one helps manage the food spawning logic. Before the game actually starts, I draw the play area using the initialize game zone function. This is where I draw the black rectangle inside the background border we set up visually in Visi. This rectangle becomes the actual boundary the snake has to stay inside. I also set the starting position for the snake, draw the first 3 segments, and place the first food block randomly somewhere on the grid. Now we get to the actual movement. The snake's movement is handled by the animate snake function, and this is triggered by a timer. That means that the snake moves on a fixed interval. The update snake function is where the classic snake behavior happens. The head moves first, then every other segment shifts forward to take the place of the one in front of it. The last segment gets erased to create the illusion of smooth movement. This is also where I check self-collision, so if the head collides with any part of the body, the game triggers the game over sequence. Next up is the food. I've got 2 functions, place initial box and place new box. They randomly generate a spot on the grid and draw a square there. When the snake's head reaches that position, the game increases the snake length by 1 segment and generates a new food block in a different position. And finally, the game over function handles what happens when you lose. For this project, I'm using the user image frames that we imported earlier. They flash a couple of times to give a simple game over animation, and then the entire game resets by reinitializing the play area and starting the movement timers again. So it's a full loop, play, lose, restart, without needing to reboot or load anything manually. And that's essentially how the entire code works. It might look complicated, but once you break it down into grid logic, the movement, the joystick input, and the timers, it all becomes really easy to understand. With all the code now written up, we are finished with this program. I can now go ahead and check my project settings and then flash this to my display. And there you go, a simple and fun project using real hardware that anyone can do. If you would like to take a look at the 4D Systems products used in this video, please check out our website linked in the description. If you have any questions, please visit the 4D Systems Resource Center, and of course, if you would like to see more project videos, please subscribe. Thank you for watching and see you next time.